PowerLab is focused on experimental validations of complex energy systems, which are a combination of multiple components of interactions. This lab is divided in two distinct areas, the one on real-time system simulation and the one in power conversion experimentation. This setup allows us testing rigorously the hardware's performance in complex real-world scenarios under controlled operating conditions before deploying all this hardware in real pilot settings. In this setup, we can integrate the real hardware into the real-time simulation loop by using advanced measurement systems and power amplifiers, compatibilizing the digital signals with the real-world power signals. Okay? In addition, we can integrate networks, communication networks into such a real-time testing, evaluating the impact of contingencies and also cyberattacks in the performance of the final system.
Here we are having a real-time simulation for the electrical distribution and transmission networks for real-time simulation studies. And for wide area measurement system purpose, we are using the actual PMUs using low voltage interfacing from these real-time simulators. And for monitoring purpose, these phasor measurements are sent to the phasor data concentrator in Wamster PDC.
So here within the framework of Horizon Europe project Reforming, we are working on a multi-port converter that has 4 ports connecting to the power grid, to the fuel cell, to EV chargers, and to PV panels. And this will be a solution that can bring flexibility to the distribution grid, adding a number of functionalities to the power electronics. So here we have the real hardware devices like power converters, power amplifiers, AC sources that communicate with our real-time hardware-in-the-loop lab through Modbus to control these devices and making this connection between the physical and the virtual world within the power hardware-in-the-loop setting.
In the context of Living Lab, we have deployed several of these battery energy storage systems throughout the Luxembourg, and these battery energy storage systems are capable of providing ancillary services to the grid, such as peak shaving, congestion management, or the flexibility services.
This lab allows us offering services to manufacturers for testing their hardware performance in real-world complex scenarios under controlled operating conditions. In such a case, they can demonstrate their hardware is not only technically and economically sound, but also they can prove their hardware is performing in a reliable manner and it is operating effectively under demanding operating conditions. This lab will have an important impact in energy transition and sustainability in order to get adapted to the rapid changes of modern power systems. Today, some technologies are quite mature, like photovoltaics, but others, like energy storage, hydrogen, needs still a lot of work at the practical level. In this lab, we are going to be able to develop, operate, and control new energy systems under practical operating conditions. And in such a case, we are going to be able to demonstrate their performance and also how well they fit the user needs. Okay? At the end of the day, this lab will offer essential services for covering or fulfilling the clean energy.